Welcome to lesson 3.3, segment bisectors. Okay, so the definition of a midpoint is if segment AB is M, then M is in between, right, betweenness of A and B, so AM equals MB. So, excuse me, let's think of that in a different way. What if I had a piece of string, and we said one end of the string was A, the other end of the string was B, and I folded it in half. Okay, that halfway mark would be M, or the midpoint of that piece of string. Okay, and that means AM would be equal to MB. Alright, similarly, what if I have something I can't fold in half, like say a curtain rod, and I need to know where the middle or the midpoint of the curtain rod is? It means I would measure, right? I would use my ruler postulate, and I would measure how long it is, and I would divide that number by 2, and then I would have the middle, or the midpoint. Okay, so similarly, we have the midpoint theorem, which says if M is the midpoint of the segment AB, then AM is half of AB. Okay, since M is the midpoint, it has to be between, so that's the betweenness thing. It has to be between A and M, and also AM equals MB, which is the definition of a midpoint. So betweenness is guaranteed, and then by substitution we can say that we have half, two halves make a whole, right? So for the first time ever, we're going to look at a proof. Okay, so we're going to just say that M is the midpoint of AB, and that's going to be our given. Okay, in a proof, you're always given a statement to start with, and then you're given a statement to prove. Okay, so we're going to try to prove that AM equals half of AB. So we're proving the midpoint theorem. So given that M is a midpoint, we need to start with definition of midpoint because that's all we have in our given is a midpoint. So AM equals MB, and M is between A and B. So that's the definition of a midpoint, and that's all we were given, was that it's a midpoint. Okay, so you can't, the trick with proofs is not taking too big of steps. Okay, it's sort of like if you were needing to cross a creek and the rocks were too far apart, you'll get wet. Okay, but if I'm going to cross a creek and the rocks are just a step apart, I'm going to be able to step without getting my feet wet. Okay, so that's similar to here. We're putting a puzzle together. Okay, so I want you to pause right now, and what do you think the reason for AM plus MB equals AB? What is that definition? I'll just give it to you. It's a definition. Okay, it is the definition of betweenness. It's our newer definition that we learned this chapter, our new and improved. Okay, and I'm saying here that AM plus AM equals AB. Now, how can I say that? If AM plus MB equals AB, how can I say that AM plus AM? Okay, substitution. And the reason why I can substitute is because they're equal, right? I said that above, that AM equals MB on step 2. So if they're equal, then I can substitute in. And then if I combine like terms, we haven't heard that in a while since algebra, right? Combine like terms, I have 2 AMs. 2 AMs equal AB. Well, I want to, okay, officially this is distribution, but you can also just say collecting like terms. I would know what you meant, but you need to get used to that this is officially a property. Okay, and then what if I'm solving for AM, right? So I want AM by itself, so I need to divide both sides by 2. Now, isn't this what I want to prove? And how am I able to do that? How am I able to divide both sides by 2? Remember, there's not a division property of equality, but if I multiply both sides by 1/2, I'm officially doing the multiplication property. Okay, and you just prove. Okay, and another definition we have today is the bisector of a segment. Okay, so this curve intersects the segment at the midpoint. So that means both sides of the segment are congruent. Now, this is a sketch. I didn't measure, but it's pretty close. The curve we would make with a compass. So we're actually going to do this construction later, but it's really important that you understand the difference between a bisector and a midpoint. Okay, the point on the segment is the midpoint, but the curve is bisecting the segment. Okay, here's where things get a little hairy. Congruent segments are segments that have the same length. And we use this symbol. It's an equal sign with a little curvy on top, and it's used to mean congruent. Okay, there is a difference between congruent and equality. Okay, and we have to be careful in our symbols when we write them. So I want you to think back about the difference between equivalent sets and equal sets from chapter 1. Okay, if you can remember that equivalent sets have the same number of elements, but equal sets have the exact same elements. So they apply to segments. So let's talk about it for a second. Equivalent segments, which are called congruent, and segments consisting of identical sets of points are called equal. Okay, so if we say congruent segments have the same size or length, and equal segments share the same set of points. Okay, so AB is equal to CD if the endpoints of each segment are the same point. So like A would have to equal C. Alright, and I know this verbally, not seeing a picture, this is a little bit more difficult, but we'll be drawing pictures in class. I just want you to know that two segments aren't generally equal, okay? They are generally congruent and have the same length. They aren't the same segments, okay? The exact same. Equal means the same, congruent means the same size. Okay, so let's do an example of congruency. So I have to prove that CD is congruent to EF. Do you see they are not the exact same segment? They don't share any points. So that's why we're going to be talking about congruency right here. So we use our distance equation that we know, where we take a point and we subtract it off and we do the absolute value. So we know the distance of CD is 6. So now I need to know the distance of EF. They are both 6, so they are equal measure. Okay, see how I didn't use the segment notation and I used equal? So CD, the length of CD and the length of EF are equal, so therefore they are congruent. And for your WSQ summary, you're going to do a series of practice problems. Okay, number 1 is much like the example we just went over. So I will see you in class.